everyone. I welcome you all to the lecture 10 of this course, Construction Methods and Equipment Management. Okay, in this lecture, we are going to discuss about the earth moving equipment, specifically about the bulldozers. So, in the last lecture, I introduced you to the various fundamental terms related to earth moving operations, like how to determine the power requirements of the machine and what is the significance of performance chart, how to quantify the payload of the machines. So, all those terminologies related to the earth moving operations were introduced in the previous lecture. Now, let us see what is the outline of today's presentation. So, in the today's presentation, we are going to discuss about what are all the applications of the bulldozer. Okay. So, there will be some series of lectures on different earth moving machines. Okay. So, in this lecture, we are going to discuss about the bulldozer. Okay. We will look into what are all the uses of bulldozer and what are all the different types of the earth moving blade which we use commonly for the bulldozer. Okay. So, what are all the possible blade adjustments or the blade movements with the bulldozer, how to assess the blade performance, okay. So, and what are all the different productive dosing methods which can be adopted to enhance the productivity of the bulldozer. So, the factors which affects the productivity of bulldozer and how to estimate the productivity of the bulldozer with some illustrations. Okay. So, these are the things which I am going to discuss in the upcoming slides. So, most of you might have seen the bulldozer. It is basically a tractor unit connected to a earth moving blade. Okay. So, it is nothing but your tractor unit connected to your blade. So, with the help of this blade, you can push the material from one location to another location. So, you can see that there are possibilities of different types of connection between this blade and the tractor. So, here you can see a type of connection, tilt cylinder and a pusher arm arrangement. So, with this you can adjust the blade movement. So, similarly, there are also possibilities of different types of connections, like say for example, you can have a C-frame connection like this, C-frame connection between the tractor and the blade. So, with this particular kind of connection, certain types of movements of blade are possible. So, basically the connection between the tractor unit and the blade will decide what are the possible movements or the adjustments for the particular blade. So, we will discuss about the blade movements later. So, this bulldozer is basically a versatile machine. So, it can be used for different types of applications in a construction project site. So, before you select an earth moving equipment for your particular activity or a particular job, you should know what is the haul distance actually needed for your actual job, because every earth moving equipment has its own economic haul distance. Okay. So, every equipment has its own economic haul distance. This we have discussed earlier also. So, the economic haul distance of a bulldozer, the maximum distance is only 100 meter. So, beyond 100 meter, it is not advisable to use this particular machine. You won't get your desired productivity, and it will, if you use it, it will result in a lot of wear and tear for the particular machine. Okay. So, this machine is designed only for a haul distance of up to 100 meter. So, the actual distance will decide depending upon your size of your machine, size of your dozer and the type of the material which you are going to handle, which you are going to push, which the bulldozer is going to push. Say if you are going for a bigger tractor, bigger bulldozer, the economic haul distance may be slightly higher than this. So, the actual distance depends upon the size of the dozer. Greater the dozer, the economic haul distance will increase. Similarly, it also depends upon the material which the bulldozer is going to push. Say some material or cohesive, some material or non-cohesive. Say generally the bulldozer can push a cohesive material more easily when compared to non-cohesive material, like sand. Okay, like sand is non-cohesive material, because a cohesive material can easily roll in front of the blade. Okay, so it is easy to push, but your sand, it will remain like a dead material, it won't roll easily. So, the pushing of the sand is little bit difficult with the bulldozer. So, in that case your haul distance will get reduced. What is the haul distance possible depends upon your size of your bulldozer, and it also depends upon the type of the material which you are going to push with the bulldozer. So, commonly you can say the maximum haul distance is up to 100 meter. So, apart from the earth moving machine operation, you can use this machine for so many activities. Okay. So, you might have seen bulldozer used for cutting trees. Okay. So, it can also be used for clearing the vegetation at the construction site. So, for opening up of roads through mountain, it is a very common supporting machine. So, very commonly it is used as a supporting equipment. Say for example, for pushing or towing other machines, this can be used. Say this scraper is another earth moving machine which we are going to discuss in the upcoming lecture. So, this scraper will also cut the earth. Okay, there will be a bowl in the scraper, there will be a blade. With the help of the blade you can cut the earth and fill the bowl in the scraper. Okay, so this is called as a loading operation. During this particular loading operation, I can take the help of a bulldozer to push the scraper, okay, so that the job of the scraper will be easier. So that this is used as a supporting machine. Similarly, spreading. So you can use the bulldozer for spreading the earth, for preparation of your subgrade for your road or whatever, for spreading the earth, for filling the trenches, okay, for backfilling the trenches, for maintaining the haul roads. Okay, so for different applications it is used. That's why we call it as a versatile machine. So let us see some examples. Now you can see this bulldozer can be used for land clearing. So it is used for cutting the trees, okay, clearing your site. So these are special bulldozers. For this purpose we should not use an earth moving blade. There are special land clearing blades. Okay, it is called as land clearing blade. One such land clearing blade is Rome K-bar-G clearing blade. It is a very powerful blade manufactured by Rome company. So this blade, okay, you can see it has a vertical knife called a stinger, okay, vertical knife called a stinger, and the horizontal knife called as web. So it has both vertical knife and the horizontal knife. So with this you can easily cut the trees. So generally for cutting the trees you need more tractive effort, more power is needed. So you have to use a very big bulldozer. So you have to choose a very big tractor unit so that you will be able to deliver more power. And one more important thing you need to note is there is cutting edge at the bottom of every blade. So generally when you use the blade frequently, the one which gets worn out very fast is the cutting edge. So we do not replace blade very often, we replace the cutting edge only. The cutting edge is just bolted, okay, it is just bolted at the bottom of the blade. So once it gets worn out, you can just replace it with a new cutting edge. So generally we do not replace blade frequently, but we replace only the cutting edge at the bottom of the blade. So this is what I told you earlier. The bulldozer is used for assisting other machines. So it is the supporting, it is supporting the other machines. Okay, so this is your bulldozer. So it is just a schematic sketch. So the leading one is your scraper. As I told you, this scraper has to cut the earth and fill its bowl. So during that loading operation, your bulldozer will push. You can see it has a special type of blade just for pushing it. Okay, that blade is called as cushion blade. I will explain you later when we discuss about the type of blade. Okay, so this bulldozer will push the scraper during the loading operation of the scraper. So that by that process you can enhance the productivity of your scraper. Okay, you can enhance the productivity of your scraper. Okay, so this is one application of the bulldozer. So other application you can see, it can be used as a ripper. So for this tractor you can see at the front end you have this blade, earth moving blade. This is the earth moving blade. So at the rear end you have this ripper. So this is similar to plough, what we use in farming. So basically when we discussed about the earth moving operations, the steps involved in the earth moving operations, I told you like the first step is we should loosen the earth before digging it. So when you loosen the earth before digging it, the digging becomes easier. That will enhance the productivity of the digging job. So that is why first, say for example, particularly for the hard terrain, if it is going to be a consolidated clayey terrain, in that case first use a ripper, then to loosen the earth with the help of the ripper. Once after you loosen it, then use the earth moving blade and push the earth. So you can follow this sequence so that you can enhance the productivity of the job. Similarly, even before using scraper, okay, scraper is also another earth moving machine. Before using the scraper, I can use a bulldozer with a ripper attachment. Loosen the earth first, then use the scraper for loading. Thereby you can enhance the productivity of the scraper. Okay, so this ripper is basically to loosen the material. You can also use this for ripping the rocks. So this can also be used for ripping rocks. So you know that the commonly adopted method for excavating the rock is drilling and blasting method. So that is actually always a costlier method. So if you are able to use a ripper for ripping the rock, you can have a huge saving in the cost. So first, before that, you have to check the rippability. You have to check the rippability of your rock. Check the rippability of your rock. For that, there are some special methods like seismographic methods. Okay, we are not going to discuss that in this particular lecture. There are some seismographic techniques, seismographic techniques. Based upon that, you can check whether the rock is rippable or not. Okay, once you know that the rock is rippable, you can use this technique for ripping it. That will result in huge saving in the cost. Similarly, you can use it also for ripping your old pavements. So it can have different applications accordingly. Then stripping. Stripping is a very common operation in the construction project site. So you know that stripping is nothing but removal of the top layer of the soil. So if the top layer of the soil is weaker one with a lot of vegetation, so you have to remove the top layer of the soil. So depending upon the depth to which the vegetation is available in your soil, accordingly you have to remove the top layer. Okay, so that is what is stripping. So bulldozer you can see very commonly used for stripping the top layer. So as I told you, the bulldozer is economical only for the haul distance up to 100 meter. The actual distance depends upon your size of your dozer and also the material which you are pushing. So if you are pushing a cohesive material, it is easier for the bulldozer to push. So you can have a little bit greater the haul distance. But if you are going to push the sand which is non-cohesive, in that case your haul distance is still going to be reduced. Okay, it depends upon the type of material which you are going to encounter in your project site. So what are the other uses? The bulldozer can be used for spreading, backfilling. Okay, so here you can see the example of spreading. Your truck, okay, very commonly you can see this in the road construction. The hauling equipment, there is a truck, so it will dump the material, and your bulldozer is used for uniformly spreading it, okay, and it will compact it to the required thickness. So it helps in spreading the material. Then backfilling. So when you excavate a trench, say for example for pipe laying, you are excavating the trench, okay, with the help of the bulldozer, push the material into the trench. That is, you can backfill the trench. So there are different applications in a project site. So now let us look into what are all the different types of bulldozers based upon the mounting. So there are, obviously you know that there are two possible mountings. One is your wheel mounted bulldozer, other one is your crawler. Crawler is nothing but track. You can see the track mounted. Okay, so crawler is nothing but your track mounted. You can see chain type of track. You can see that. So now let us compare what are all the merits and demerits of these both the cases. If you go for wheel mounted bulldozer, obviously the main advantage will be its mobility. So this one will have very high mobility. This has very high mobility. Okay, I mean the speed will be very high with the wheel mounted machines. But with a crawler mounted machine, so there is a restriction on the speed. Okay, you won't be able to realize the speed, the similar speed what we realize with the tire mounted machines. Okay, so and another important thing is you can easily mobilize this machine, wheel mounted. Mobilization is easier. Mobilization to the project site, okay, is easier. You can even take it on the highways without damaging the highways to the project site. But in the case of crawler mounted, you need another equipment to mobilize this machine to the project site. So we cannot use it on the highways, it will damage the highways. Okay, so this mobilization is a little bit difficult. But when you look into the tractive effort, okay, so which one will deliver more power? You know that obviously the crawler mounted will deliver more power because this track mounted has broader contact area, so the traction developed is more. Okay, so this develops more tractive effort. That is why for most of the tough conditions, say for example ripping rocks, cutting trees, okay, all these are tough jobs. For that we generally go for only crawler mounted because that will be able to deliver more tractive effort. We know that already how to estimate the usable force. The usable force is nothing but your coefficient of traction multiplied by weight on driving wheels. So compare two cases, okay, two different types of bulldozers you have with two different mountings. Say one is wheel mounted, other one is crawler mounted. Okay, so assume that both are of same weight. The gross weight of both the machines are same. Okay, so you are going to operate this machine on a clayey terrain. Okay, clayey terrain. So obviously, which one will have better coefficient of traction? So when compared to the tire mounted on a clayey terrain, definitely your crawler mounted will have better coefficient of traction. So there will be proper grip between the track and the haul route. So what happens if you go for your, say, when you consider your track mounted or crawler mounted bulldozer, here the coefficient of traction, say it may be approximately 0.9 on a clayey terrain. So here for the wheel mounted, the coefficient of traction may be only say 0.5. So for the same weight of the machine, since the coefficient of traction is very high, obviously you can see that the usable force which is generated by this crawler mounted is going to be very much high when compared to the wheel mounted bulldozer. So that is why I told you, for very tough job conditions you have to go only for the crawler mounted. And similarly for poor underfoot conditions, as I told you, for clayey terrain, muddy terrain or rocky terrain, because in the rocky terrain you cannot use your tires, okay, that will damage your tires, okay. So you have to go for this crawler mounted. Similarly, if you want to climb a very steep terrain, it will be more easier to use a crawler mounted machine when compared to wheel mounted machine on steeper slopes, okay. So all these things you should note it when you select your machine. So let us now summarize what are all the advantages of the crawler mounted dozers and wheel mounted dozers. It has excellent traction. Crawler mounted has excellent traction, as you know, okay. So it has ability to move over rough terrain, your muddy surfaces or rocks or steeper grades, okay, everything can be handled by the crawler mounted machines, okay. But your wheel mounted machines, the main advantage is it can operate at a high speed and its mobilization is very easier. It can be operated on paved road without damaging the surface. Hence, there is an elimination of hauling equipment to transport the bulldozer to the job site, okay. So it can be used on the paved highways and it can be easily mobilized to the project site. But here you need a separate hauling equipment to carry this crawler mounted bulldozer to the project site, because this crawler track may damage your highway, okay. It cannot be taken on the public highways. So now let us to look into the blade adjustments. So what are all the possible the blade movements with the bulldozer blade? As I mentioned earlier, the movements which are possible depends upon the connection between the tractor and the bulldozer blade. In some bulldozers you can see this kind of C-frame connection, okay, between the tractor and the blade. So those the tractors will facilitate certain kind of movements like angling. Similarly, some the bulldozers, they have this kind of tilt cylinders and pusher arm arrangement, okay. So in those bulldozers some of the movements are possible. So we will discuss what are all the possible movements in detail in the upcoming slides. So basically pitching, tilting and angling, three types of the blade movements which are commonly seen in the bulldozer blades. So what is this pitching? So pitching means the top of the blade is pitched forward or backward. That means you are moving the top end of the blade either forward or backward, okay. So this top end of the blade is moved forward or backward. So why should we move it forward or backward? So accordingly you can change your angle of cutting. Accordingly you can change the depth of penetration of your blade. Say for example, if you move the blade, the top end of the blade forward, it means what happens? So when you move the top end of the blade forward, it will decrease the penetration of the blade into the soil, okay. So similarly, if you move the top end of the blade backward, it will increase the penetration of the blade into the soil. So by pitching it forward or backward, either I can increase or decrease the depth of penetration of the blade into the soil. So generally when we do the earth moving operation, you can see that the bulldozer will be cutting the earth, okay, for some distance, okay. Once the blade is full, after that it won't cut because the blade is already full. Then you have to just push the loaded earth to the required dumping place, that's it, okay. So when you just want to push the material, okay, so you can reduce the depth of penetration, okay, of the blade into the soil, okay. So in that case you can pitch the blade forward, okay, so that you can reduce the penetration of the blade into the soil. So that is the purpose of pitching. By pitching it forward or backward, so you can change the angle of attack or the depth of penetration of the blade into the soil. So how much is the pitch possible for the particular blade is defined by the manufacturer. So in the specifications given by the manufacturer, you can see, say for example, it may be mentioned 5 degree. So that means the maximum pitch possible with this blade is 5 degree. Now coming to tilting. Tilting is the next type of movement. So basically this is a movement in the vertical plane. So you can raise one end of the blade and lower the other end. So you can raise one end of the blade and lower the other end. So tilting is a difference in the elevation of the two ends of the blades. It is a movement in the vertical plane. Why should we tilt the blade? So basically when we encounter a tough terrain like very hard soil or consolidated clay, okay, in a very tough terrain we need more concentration of power. So if you raise one end of the blade, only the remaining portion is in contact with the ground, okay. So only some portion of the blade is now in contact with the ground. So the concentration of power will be more in that limited portion of the blade. So it will be very easy to cut the hot terrain, okay. So particularly to cut the hot terrain, you have to tilt the blade, okay, so that I can increase the concentration of the power in the available portion of the blade. So basically either end of the blade is raised or lowered in the vertical plane. The concentration of the power in the limited portion of the blade's length, it helps in cutting the ditches. So it helps in cutting the soil in a very hot terrain. So next we shall see what is this angling. This angling is possible only if there is a C-frame connection between the tractor and the blade. So basically you can see in most of the tractors the blades are fixed perpendicular to the direction of motion. You cannot angle the blade either to left or to the right. In conventional bulldozers what you see, okay. But in some dozers where you have this kind of C-frame connection between the tractor and the blade, there is possibility to angle the blade either to the left or to the right, okay, to maximum say 25 degree angle the blade. Basically the angle refers to the angle between the center line of the blade and the line perpendicular to the center line of the tractor. So if you are going to work on one side of a road, okay, say for example you are doing some pipe laying, okay, you need to backfill the trench, okay. So you are working on one side of the road. In that case you can easily angle the blade and backfill the trench, okay. Similarly for side hill cutting, and when you are working in narrow constraints, okay, narrow space constraints, okay, in that particular places the angling will be very easier, okay. So you can just strip the soil and deposit the soil in windrows of soil. So using this angle blade it is very easier to do. But basically angle blade are not considered a highly productive blade with respect to earth moving operation, okay. It is not very good in cutting and pushing the earth. I will be discussing that in detail when we discuss about the types of blades. So we have discussed about the three types of movements. One is pitching, other one is tilting and angling, okay. There are different types of blades which we are going to discuss in upcoming slides. You need to note that like for every type of blade only two movements are possible, okay. Either you can go for angling and tilting or you can go for the pitching and tilting, okay. So these are the two options. For every blade only two movements are possible. Blade performance. Now let us see how to assess the performance of the blade. So there are some indicators of blade performance, okay. There are some parameters which quantify the performance of the blade. Say one is cutting ratio, other one is the load ratio. The cutting ratio indicates what is the cutting ability of the blade. So what is the cutting ability of the blade? I can know it from the cutting ratio. So it is defined as horsepower per meter of the cutting edge of the blade, okay. So first of all you need to know what is cutting edge of the blade. So generally when we look into the bulldozers, okay, I have shown this picture earlier to you. At the bottom of the blade you can see a plate bouldered. I mean this is the blade, okay, this is the blade. At the bottom what you have is the cutting edge. A steel plate is bolted to the bottom portion of the blade, that is called as a cutting edge. So generally this cutting edge gets worn out faster depending upon the usage. You need not replace the blade frequently, you need to replace only the cutting edge frequently. So this is easily bolted on to the bottom of the blade. So, we were discussing about the cutting ratio. Okay. So, cutting ratio is nothing but horsepower per meter of the cutting edge of the blade. So, that means it depends upon the concentration of the power in the cutting edge. If the blades are smaller in dimension, then you can see the more horsepower concentration will be there in the smaller blade portion. So, those blades will be very aggressive. Okay. So, that can easily cut the earth and move the earth. Okay. So, that can easily cut the earth. Okay. So, cutting ratio measures the blade's ability to penetrate the hot soil and obtain the load. If I say the blade has high cutting ratio, it means it can easily cut the soil and obtain the load. So, even it can to handle a very hot soil conditions, it can easily handle if it has high cutting ratio. So, higher ratio indicates more aggressive blade. Generally, blades which are smaller in dimension, has high cutting ratio, because obviously there will be more concentration of power in that portion of the blade, because the blade dimension is smaller. So, those blades will be more aggressive and they will have high cutting ratio. Okay. So, next is about the load ratio. Load ratio indicates the pushing ability of the material. So, it is nothing but the horsepower per loose meter cube of material retained in front of the blade. So, you have to clearly note here the volume of the material is indicated as loose meter cube. That means the material is in loosened state. After the material is cut, we are going to, it is already in the loosened state. Okay, you have excavated the material, you have cut the material. So, the material is in now loosened state and you are going to push the loosened material. Okay. So, what is the pushing ability of the blade? That is what is indicated by the load ratio. Horsepower per loose meter cube of material retained in front of the blade is load ratio. So, it measures the blade's ability to push the load once the blade is loaded. So it is not referring to the blade capacity, that is different. Okay. So, this is nothing but it refers to the pushing ability of the blade. So, generally if the soil is highly dense, in that case the blade will find it difficult to push the soil. If the soil has less density, it will be easy to push. Okay. So, it depends upon the type of material which you are going to push. Okay. So, generally higher load ratio means a dozer can push the load at a greater speed. It indicates the pushing ability of the material. That depends upon the type of the material which we are going to push, and also it depends upon the type of blade. So, as it is mentioned, it is horsepower per loose meter cube of material. If the blade is smaller in dimension, so there will be more concentration of power per meter cube of material in the front of blade. So, those blades can easily push the material. So, smaller blades will also have high load ratio. So, it not only has high cutting ratio, it also has high load ratio. Smaller the dimension, more concentration of power will be there per loose meter cube of material retained in front of the blade. So, those blades can easily push the soil okay, at the greater speed. Okay. So, this is how we assess the performance of the blade. Now, let us look into what are all the different types of the blade. Okay, these are the common blades which are used for the earth moving operation. Okay, straight blade, angle blade, universal U blade, semi U blade and cushion blade. Okay, so these are the standard notations used. S refers to straight blade, A for angle blade, U for universal, SU for semi U and C for cushion blade. Okay, so we are going to discuss all these blades one by one in the upcoming slides. So, first we are going to discuss about the straight blade. Straight blade, it is denoted as S blade. As the name indicates, straight, that means your blade is fixed straight perpendicular to the direction of the travel. So, this blade I cannot either angle it to left or angle it to right. Angling is not possible with this blade. It is fixed perpendicular to the direction of the travel. Okay. So, that we have to note it. Okay. So, you can see the type of connection. These blades are commonly connected to the tractor by this kind of tilt cylinder and pusher arm arrangement. So, with this we can have the possible blade movements. So, what are all the possible blade movements with this kind of arrangement? One is pitching, other one is tilting. So, only these are the two movements possible for this blade. As I mentioned earlier, angling is not possible with the straight blade. So, it is fixed perpendicular to the direction of the travel. Okay, I hope you remember what is pitching. Pitching means you can pitch the top end of the blade forward or backward. So tilting means I can raise one end of the blade upward and the other end of the blade I can lower it downward. Okay. So it is a movement in the vertical plane. Tilting is the movement in the vertical plane. Okay. So only these are the two movements possible with this straight blade. And another important thing to be noted is, generally all the bulldozer blades, most of the bulldozer blades have the curvature in the vertical plane. Okay. So the blades will have the curvature in the vertical plane like this. So what is the main purpose of the curvature? You can see in this picture also a curvature in the vertical plane. So what is the main purpose of the curvature? See, you want to push the material. So the material should roll in front of the blade. To facilitate the rolling effect, we have this curvature, so that the material can easily roll. For the rolling purpose, to make the material easily roll in front of the blade, I have the curvature in the vertical plane. All the blades will have the curvature in the vertical plane, but there are some blades which also has the curvature in the horizontal plane. So some blades, you can see it will have a curvature in the horizontal plane also. The blade is curved like this. So the main reason why the blade is curved like this is so that the material will be contained. Okay, material will be contained inside, and you can reduce the spillage of material at the ends. At the end, always when the dozer blade is pushing, there will be some spillage of material at both the ends of the blade. Say this is the blade, at both the ends of the blade there will be some end spillage. To reduce the end spillage, some blades have the curvature in the horizontal plane also, that is along its length. So in the length also you have a curvature. So those blades are called as U blades, that we are going to discuss later, but what I am trying to say here is, in the straight blade you do not have the curvature in the horizontal plane. Okay. So this blade is straight, that means it has a curvature only in the vertical plane, it does not have a curvature in the horizontal plane, and this blade is fixed perpendicular to the direction of travel. You cannot angle it to the left or right. Okay. This is what is to be noted. So the blade is supported by pusher arms and tilt cylinders. The blades have no curvature across the length, and they are mounted in a fixed position perpendicular to the dozer line of, so it is fixed, you cannot angle it. So what are the possible movements with this blade? It can be tilted and it can be pitched. So these blades are generally smaller in dimension. Straight blades are smaller in dimension. So what are the benefits of having smaller blades? You can have high cutting ratio and high load ratio. That means these blades will have high cutting ability or penetration ability, and it will also have high load pushing ability. So generally when you are going to encounter hard terrain, it is preferable to go for these kind of smaller straight blades. So it can easily handle the harder terrain. Now let us move on to the next type of blade, that is the angle blade. So these angle blades, as I discussed earlier, they are connected by C-frame. Okay, the C-frame is connecting the tractor and the blade. So because of this C-frame, it facilitates the angling movement. So you can see the angle can be turned left or turned right to maximum of say 25 degree. So it is mounted on a C-frame and can be angled up to a maximum of 25 degree left or right of the perpendicular of the tractor. So we have already discussed the main applications. So when you are working on one side of the road or side hill cutting, or if you wanted to backfill the trench, all these operations can be easily done by this angle blade. So you can turn the blade to left or right, so that it is not just perpendicular to the direction of the dozer travel. So this rolling the material to one end of the blade is called as side casting. So with this help of this blade, I can just roll the material to one end of the blade, and that is called as side casting. So this blade can easily do the stripping work and deposit the material in windrows. They call windrows of soil. So what are the possible movements with this blade? One, obviously I can do angling. I can angle it to the left or right, maximum of 25 degree, and I can also tilt it. Tilting is also possible, but pitching is not possible. So because of the C-frame connection, I won't be able to pitch my blade. So I cannot pitch the top end of the blade forward or backward. That is not possible with the angle blade. Only possible movements are angling and tilting. These blades are not considered as highly productive blades for earth moving operation when compared to straight blades. So the productivity will be only 60% of the straight blade. Okay, but this is for a special application, as I told you. Universal blade, U blade. Okay, this is what I mentioned little bit earlier. Like this blade has a curvature in the horizontal plane also, and all the blades have the curvature in the vertical plane. In addition, these blades also have the curvature in the horizontal plane. So you can see the curvature in the horizontal plane in the form of U. So what is the purpose of this U? So that I can contain the material within the blade. So these are generally larger blades. Okay, their dimension is very much bigger when compared to straight blade. You can see kind of wings are attached on both the ends. So they call these as wings, the left wing and right wing. So it increases the dimension of the blade. These are bigger blades. Okay, you can see at the bottom cutting edge. This is the cutting edge, and you can see the U curvature. So because of this U curvature, I can contain the material within the blade. I can reduce the end spillage. That is the main advantage of this blade. End spillage can be reduced at both the ends. So these blades have large blade capacity. Okay, blade capacity is high because they are bigger blades. The dimension is bigger. So that's why the blade capacity is bigger. But one thing to be noted, the cutting ratio and load ratio, okay, these are lower for U blade when compared to straight blade. So the cutting ratio and the load ratio are lesser for this U blades when compared to the straight blade because they are bigger in dimension. Only smaller blades can have high cutting ratio and the load ratio because of the greater concentration of the horsepower per unit meter of the cutting edge. But here, since the blade dimension is bigger, these have lesser cutting ratio and load ratio. So then where do we use this blade? See, if you are going to handle some average terrain is soil conditions are not that dense, soil conditions are not that hard to handle. So for lighter materials, it is the right choice. It can easily push the lighter material which are less denser, and you can use it for a relatively longer distance, less end spillage because of the U curvature. The end spillage is less. For those applications, you have to choose this U blade. So you can see the blade is curved over its length. The shape of U blade reduces the spillage of the loose material. So the possible movements are tilting and pitching. For this blade, only tilting and pitching possible. Only for the angle blade, you can do angling. For all the other blades, you can see that most of the other blades, you can see the common movements possible are only tilting and pitching. Cutting ratio and load ratio are lower for U blade than the S blade. It is best suited for the lighter materials. Okay. So this is again a schematic sketch showing the U blade connected to the bulldozer. You can see they are larger in dimension and they have a U curvature, and you can see the wings attached on both the ends. Now let us see what is this SU, semi U blade. Okay, it is something between straight blade and U blade. Okay, it is between S blade and U blade. That means its dimension is bigger than the S blade but smaller than the U blade. Similarly, cutting ratio is lesser than the S blade but better than the U blade. So it's something between the S and U blade. So accordingly, you have to make the choice according to your requirement. Then let us see what is this cushion blade. Okay, I have shown this picture earlier. So when we discussed about the application of bulldozers, I told you that the bulldozers are also used for supporting the other machines. So it helps in assisting the other machines in its job. Say this is the schematic sketch showing a scraper. So this is the bulldozer. So your bulldozer is helping to push the scraper. So this scraper is also an earth moving equipment. We are going to discuss about this equipment in detail in the next lecture. This scraper has a bowl and a cutting edge. So the scraper will cut the earth and fill the bowl. Okay, that is called as a loading operation. So during the loading operation, I have to supplement the power of the scraper with the help of a pusher. This pusher is nothing but your bulldozer. So this bulldozer will supplement the loading power of the scraper. Thereby you can enhance the productivity of your scraper. So only during the loading operation, I need the help of the bulldozer. Okay, so for those bulldozers, okay, so I am not going to use a blade for earth moving operation. So I need a blade for just pushing the machines. That blade is called as cushion blade, C blade. These blades are generally, the height will be shorter, okay, the height is shorter, so that the height of the blade won't disturb the rear wheel of the machine which it is the pushing. So, the blade height is shorter, and this blade no movement is possible. I cannot tilt or pitch or angle, nothing is possible with this the cushion blade, it is just fixed. So, these cushion blades its productivity is also less, okay, with respect to earth moving operation. It is not commonly used for earth moving operation, it is used primarily only for pushing the other machines. So, we have discussed about different types of blades so far. So, straight blade, U blade, okay, angle blade and cushion blade and SU blade. Okay, straight blade, as I told you, for harder terrain you have to go for straight blade because their cutting ratio and load ratio is high. But the problem with a straight blade is you will have end spillage. Okay, when you push the earth, there will be spillage of material at both the ends of the blade. That will reduce the productivity of the bulldozer. So, in that case, I have to go for the U blade. If you wanted to reduce the end spillage, you are going to push the material for a longer distance, and if the material is easier to handle, it is preferable to go for U blade, because U blade has a greater blade capacity also, bigger in dimension. Okay. So, similarly, the cushion blade, it is used only for pushing the other machines. When the bulldozer is used for assisting the other machines, then I can go for the cushion blade. Okay. Now, let us see what are all the different the dosing methods which are commonly adapted to enhance the productivity of the bulldozer. To enhance the productivity of the bulldozer, I need to reduce the end spillage of the material which is happening at both the ends of the blade. How to reduce the end spillage? What are all the dosing methods which can help me to reduce the end spillage? So, one such method is your slot dosing method, slot dosing. So, basically how to carry out this slot dosing, you have to divide your land, your area where you are going to do the dosing operation into many parallel cuts, divide it into parallel cuts. So, if you have a larger area, it is easy to implement this method. Okay, divide your area into parallel cuts and allow the bulldozer to move through alternative cuts first. Let it move through alternative cuts first. So, when the bulldozer is moving through these cuts, obviously at the both the ends you can see the end spillage will be there. As the bulldozer is pushing the earth, there will be end spillage of material at both the ends of the path. So, here also the end spillage is there. So, now this end spillage, it will act like a wall. The end spillage will act like a wall for the subsequent passes, So, now after this, now you allow the bulldozer to go through the gap between the two cuts. So, now we are going to allow the bulldozer to go through the gap between the two cuts. So, when this is now going through this gap, already the end spillage which is formed through the earlier passes, this is acting like a wall. Since this acts like a wall, the spillage, further spillage is reduced when the bulldozer is passing through this path. Similarly, when it is passing through this path, already you have end spillage formed here, that will act like a wall. So, this wall will prevent the further spillage during this pass. So, by this method I can reduce the spillage and I can increase the productivity from 20% to 50%. So, basically you are going to leave some uncut section between the slots. So, these are the uncut sections. You have left the gap between the slots. So, first you finish these slots, then come back to this uncut section. When you do this section, the earlier passes spillage will act like a wall for this the passage. So, this will further prevent the spillage. So, the side walls from the previous passes reduces the further spillage. So, this will increase the production, as I told you, from 20 to 50%. This is one method which is commonly followed to reduce the end spillage and to increase the productivity of the bulldozer. So, now let us see this picture also indicates the slot dosing. So, you can see when the bulldozer is moving through this the particular cut, you can see the end spillage being formed at both the ends of the blade. Okay, this is the end spillage. So, after this, when you go through the other passes, okay, other path, So this end spillage will act like a wall for the subsequent passes. The end spillage formed during this particular pass will act like a side wall for the subsequent passes. Okay, when the bulldozer is passing through this path, this will act like a wall and prevent the further spillage. Now let us see another method of productive dosing method to reduce the end spillage. So here what they are doing is, we have to employ two bulldozers together and maneuver it in such a way that the blades are coming closer to each other, almost touching. The blades are brought closer to each other. So when the blades are closer to each other, obviously you can reduce the end spillage between these blades. The spillage of material between the blades can be reduced. So, but the thing is, there will be some additional time taken for maneuvering. So the driver or the operator should be skilled enough to maneuver both the bulldozers in such a way that the blades are closer. So by this I can reduce the end spillage at the end of the blade. Okay, obviously the spillage is here, okay, but the spillage can be reduced here. So, but this cannot be adopted for a very short distance, for a very shorter haul distances, because you need some sufficient time for maneuvering. Okay, so there should be some sufficient distance so that you can maneuver. So this blade to blade dosing, it is also called as side by side dosing, involves two dosers operating together with their blades almost touching. Okay, it reduces the side spillage, okay, between each machine, okay, by about 50%. So you can reduce the spillage by 50%. But as I told you, like some amount of time is needed for maneuvering. That is why I cannot use it for a very short distance, say less than 10 meter, I cannot adopt this method. So because of the increase in the maneuvering time, the effective increase in production, you can see it will be about 15 to 25%. So though it reduces the end spillage to a certain extent, but it increases the maneuvering time, so the effective increase in production will be from 15 to 25%. So we have discussed about different types of blade movements, okay, and we discussed about the types of blades, how to assess the performance of the blade, okay, and also we discussed what are all the productive dosing methods to reduce the end spillage and to increase the productivity of the bulldozer. Now let us see what are all the factors which affects the productivity of the bulldozer. Okay, so obviously your blade type will affect the productivity, and the material which the blade is going to push, the type of the material, the density of the material, okay, all these things will affect the productivity of the bulldozer. How the blade type will affect, we know it already. Okay, we have different types of blades, straight blade, U blade, angle blade. Okay, so as I told you, for hard terrain, straight blade will give you high productivity. So if it is just an average terrain, loose soil, okay, I can use U blade, that U blade will be more productive. So then angle blade, it is for a special application. Angle blade is not that highly productive in earth moving operation when compared to straight and U blade. So depending upon the blade type, okay, your productivity will vary. And as I mentioned earlier, the material type, if the material is going to be cohesive, it's easy for the material to roll in front of the blade. But if it is going to be cohesionless sand, the sand will act like a dead material, okay, dead material. It won't roll in front of the blade. For this sandy soil, it's very difficult for the blade to push the soil. So the productivity gets affected. So the type, the density of the soil, everything affects. If it is going to be denser material, it's difficult for the blade to push. If it is going to be less denser, it is easier for the blade to push. So accordingly the productivity will vary. Then the cycle time. The cycle time, it depends upon how much distance you are going to travel. Say the haul distance, your path, okay, so which route you are adopting. So what is the condition of that haul route, okay, the project conditions, the underfoot conditions, okay, the underfoot conditions is going to affect your cycle time. Say what is the rolling resistance, what is the grade resistance which are prevailing there, okay, whether you are going to move up the slope or down the slope, all these things will affect the cycle time, okay. So your distance, the haul distance and the project underfoot conditions, the site underfoot conditions, okay, the resistances which the vehicle is going to encounter, all these things will affect the speed of the machine, and that is going to affect your cycle time. Okay. Now let us see how to estimate the blade capacity. The blade, so it is not like a bucket or bowl. So, how much material lies in front of your blade, that defines the capacity of the blade. It depends upon your blade type and the dimension of the blade. Obviously, as I told you, straight blade are smaller in dimension when compared to U blade. So, the greater the dimension, bigger the blade, okay, your blade capacity will be more. So, how to get the information on the blade capacity? I can get it from the manufacturer. Okay. So, the manufacturer will provide you the specifications, like what is the capacity of the blade. I can get it from the manufacturer or from your own previous experience. So, for a similar type of blade and for a similar type of a dozer and for the similar type of terrain, the material, soil. So, from your properly documented past experience, you can get the blade capacity. Okay, that is also possible. Or you yourself can do the field measurement at your project site. So, do the dosing operation, obtain a heap of earth in front of the blade. So, now you find what is the length of the pile along the length of the blade. Okay. Then perpendicular to the blade, what is the width and what is the height of the pile. Okay. So, based upon the dimensions of the pile of material, you can find the blade capacity. So, now let us see how to define the cycle and estimate the cycle time of the bulldozer. Okay, say the bulldozer is used for earth moving operation. How to define one production cycle of bulldozer? So, basically the bulldozer will cut the earth. Okay, once the blade is full, completely loaded, it will just push the earth till the dumping place, then it will return back to its original position where you wanted to do the dosing operation again. So, this cutting and pushing will go together. Okay. So, the time required to push, backtrack and maneuver into position. So, that is called as the cycle time of the bulldozer. So, you are going to cut the earth, push the earth, okay, dump it at the required place, then backtrack in the sense you are going to return back to the original position where you want to do the dosing operation again. So, and other things are maneuvering in the sense whatever adjustments you do, like for increasing the speed, accelerating or decreasing the speed, changing the gear. So, the time needed for changing the gear, all those things comes under the maneuvering. So, we call this as fixed time. Okay, this is fixed time and this one is variable time. Your push and backtrack, it is called as variable time. Why do we call this push time and backtrack time as variable time? Because it is variable dependent upon your haul distance. So, greater your haul distance, greater will be your push time and return time or backtrack time. So, this is solely dependent upon your haul distance. So, this is dependent upon your haul distance. So, that is why we call it as variable. Okay, obviously, it depends upon the speed also. So, to know the push time and the backtrack time, I need to know the travel distance or the dosing distance or the haul distance. Okay, I need to know the travel distance and I also need to know the speed. So, you very well know how to determine the speed. So, in the earlier lecture, I discussed about how to determine the speed from the performance chart. Hope you remember. So, with the help of the performance chart, you can determine the speed. So, in the performance chart, you will be having the speed in the x-axis and you have the say total resistance either in percentage or in rim pull in kg it is given. So, you can based upon the total resistance you can find what is the speed possible for that particular project condition, you can find from the performance chart. Okay, you can refer to the previous lecture to collect the information regarding this. So, basically if you know your project conditions, that means what is the total rolling resistance in your site, so that depends upon your terrain condition, and also if you know what is the grade resistance, whether you are going up the slope or down the slope. Okay, if you know that, okay, you can find the total resistance and accordingly what is the speed possible, I can determine from the performance chart. So, once you know the speed and once you know the distance, I can calculate the push time. I can calculate the push time and the return or the backtrack time. So, for that I need to know the distance, dosing distance, and I need to know the speed. Speed I can determine from the performance chart. So, now let us see what is this maneuver time. So, already I told you maneuver time is nothing but the time needed for changing your speed, accelerating, changing the gears or reducing the speed. So, that is what is called as a maneuver time. So, this maneuver time will depend upon the type of transmission. So, in all the missions there are two types of transmission possible. One is either you can have direct transmission or you can have this torque converter mode, torque converter or power shift. Direct transmission, as I told you earlier, it is nothing but manual gear change. So, the operator has to manually change the gear depending upon the load conditions. Here the torque converter, it will automatically match the engine output according to the load conditions. You need not change the gear manually. In the torque converter, it is automatic gear change. So, depending upon this the transmission mode, your maneuver time will change. Say if you are going to go for power shift, that is automatic gear change, the maneuver time is 0.05 minute. 0.05 minute in the sense 3 seconds. But your manual gear change, that is direct transmission, if you go for, it will be 0.1 minute, say 6 seconds. So, you need to know that based upon the mode of transmission, whether manual gear change vehicles or automatic gear change vehicles, depending upon the time taken for the maneuvering also will vary. Okay. So, that will also affect the total cycle time of the machine. So, if you want to make an accurate estimate, we have to consider all these things. Now, let us see how to estimate the productivity of the bulldozer. So, we are going to estimate the productivity in loose meter cube per hour. As I told you, whenever you express the volume, you should be very specific that whether you are expressing the volume in the loosened state or bank state, that is natural state, or in the compacted state. Okay. So, in which state you are referring to the material, that you have to clearly specify. So, then only it has a real meaning. So, the production here is expressed in loose meter cube per hour. That means, we have cut the earth and loosened the material. Okay. After loosening it, what is the productivity? That is what in the loosened state we are measuring it. So, it is nothing but your blade load divided by the cycle time. Okay. So, how to determine the blade load? Just now we discussed. So, you can get it from the manufacturer, what is the blade capacity, or from your own past experience you can get it, or you can do the field measurement yourself, okay, and find the dimension of the pile of material lying in front of the blade and determine the blade capacity. So, this is how you determine the blade load. And cycle time. So, the cycle time is made up of push time, return time and the maneuver. So, these two are variable. And this one is fixed time. Okay. So, just now I explained how to calculate the push time. It depends upon the distance, whole distance, and the speed of the machine. That speed depends upon the actual project condition, underfoot conditions in your project site. Okay. Obviously, the return time will be less when compared to push time, because in the return time your blade will be empty. It is an unloaded condition. So, the machine can travel faster when compared to the onward journey. So, maneuver time, you know, depending upon whether manual gear change or automatic gear change, the time will vary. So, after estimating this, you have to take into account the job efficiency. So, one thing you should know that your machine is not going to be operated for the entire 60 minutes in a hour. Okay. So, depending upon your project condition, it may operate for 45 minutes or 50 minutes. So, it may even operate only for 30 minutes. Okay. It depends upon your project condition. So, how much time the machine is operated in a hour? So, that is what is a working efficiency or job efficiency, that you have to take into account and multiply this by the job efficiency. So, how do you multiply? Say my machine is working for 50 minutes in an hour, then 50 divided by 60. Okay, this is my efficiency factor. You have to multiply the productivity obtained with this efficiency factor. Okay. So, after this you have to calculate the unit cost of production. This is a very important term, because as I told you, when you prepare for bidding, when you plan for bidding for in unit rate work, okay, in unit rate contract, unit rate work, we are very much interested in this data. What is the unit cost associated with every activity? Unit cost of earth moving operation. So, what is the unit cost of earth moving operation? So, that is what we are finding here. So, how to find the unit cost of earth moving operation? So, for that you need to know unit cost is nothing but cost per loose meter cube. Say I am going to find it in the loosened state. Cost per loose meter cube of earth moved, I need to calculate. It is nothing but your hourly cost associated with the machine, hourly cost associated with the machine divided by the hourly productivity. If we know these two data, I can calculate. So, by now you should be knowing how to estimate the cost associated with the machine. Okay, I have dedicated so many lectures on how to estimate the ownership cost and operating cost associated with the machine. Okay, so you can refer to those lectures again and find out how to estimate the hourly cost associated with the machine. You have to add all the components, the ownership, operator cost, all those should be added here to get the cost per hour. So, you know the cost per hour, say in rupees, divided by the productivity of the machine in loose meter cube per hour. Loose meter cube per hour, what is the productivity? So, if you know both these data, you can find what is the cost per loose meter cube of the earth. So, this is the unit cost of production. So, this is the data which we will be commonly using. This will be a part of what you quote in your bid. Unit cost of production of this activity forms a part of your unit cost, what you generally quote in your unit rate contract bidding. Okay. So, that is why the estimation of this is very important, and you should have some, you should accurately estimate it to the best possible, so that you can properly plan for your bidding. Otherwise, what, as I told you earlier, many times if you do not have a thorough knowledge on how to estimate the cost and how to estimate the productivity associated with the machine, you may underestimate the cost. So, if you underestimate the cost, what happens? So, you may overestimate your profit. You may overestimate your profit. Okay, this is what happens in many cases, because if you do not have thorough knowledge on how to estimate the cost and how to estimate the productivity, so this will finally you will end up in problem. You may not be able to realize the real profit which you have estimated in the paper. In real scenario, you won't be able to realize those profits, and we will end up in problem. So, what we discussed is one way of estimating the productivity. So, for that you need the information on the blade capacity, and you need the information on the haul distance, and you need the information on the rolling resistance and grade resistance, so that I can find the speed of the machine. Okay. With that I can calculate the productivity. So, another shortcut method, okay, so there are some thumb rules available provided by the equipment manufacturers. Okay. So, if you know the horsepower of the tractor and if you know the dosing distance, okay, one way push distance, okay, you can directly estimate the productivity of the bulldozer. Okay. These are thumb rules. Okay. It is nothing but your, say, net horsepower multiplied by 330 divided by D plus 50. Okay. D is your one way push distance or dosing distance in feet. So, the final resulting value of production will be in loose cubic yard per 60-minute hour. So, that means it is considered that the machine is operating for 60 minutes in an hour. So, when you use this thumb rule, according to your working efficiency or the job efficiency in your project site, you have to multiply this value with the job efficiency for your project site condition. Whether you are going to work for 45 minutes an hour or 50 minutes an hour, you have to apply that, okay, to this value. So, in loose cubic meter per 60 minutes hour, if you want to estimate the production, you can follow this formula: net horsepower multiplied by 252.3 divided by D plus 15.2. Here the dosing distance is given in meters. Okay. Here one way push distance in meter. Okay, it is given in meter. The final production value is in loose cubic meter. So, these are just approximate thumb rules to approximately estimate the productivity. So, there is also another approach to determine the productivity. So, with the help of production curves, see, some of the equipment manufacturers, they do supply these production curves for the different models which they have manufactured. So, from these production curves, this just shows some sample curves, some schematic diagram. These are not very accurate. I am just trying to show the trend of the production curves and the application of the production curves. So, the real production curves information you can get it from the equipment handbook. Okay. So, say for example, Caterpillar handbook. Okay, if you look into the Caterpillar handbook, you can see these production curves are supplied by the manufacturer for different models. Okay, you can go through the handbook, and also in some literatures like the textbook by Purify et al, you can find that these production curves are available. You can go through that. These are just some the schematic lines to show the trend. So, you can see these production curves will have the relationship between the dosing distance and the production. So, you have the average dosing distance in meter in the x-axis, and you have the production in loose meter cube per hour in the y-axis, and all these refers to different models of machine produced by the manufacturer. So, A, B, C, D, you can correspondingly look into the model. So, you can see that as the dosing distance increases, your productivity is getting reduced. Okay, your productivity is getting reduced as the dosing distance increases. So, if you know your equipment model number, so you refer to the appropriate equipment handbook, look for the appropriate model number and choose the production value directly. So, if you know the dosing distance, say the dosing distance is 60 meter and the model number is say F, so you can directly calculate the production value. So, if you know the dosing distance, if you know the model number, okay, say the model number is say F, okay, you can calculate, okay, what is the productivity. You can choose the value from this curves directly. But one thing you should know that these productivity, the production curves are drawn assuming some standard conditions. Okay, they are applicable only for standard conditions which they have assumed for drawing these curves. But your project conditions, your project site conditions may differ from these standard conditions. So, will be differing, mostly it will be differing. So, your project the conditions, if it differs from the standard conditions, then accordingly you have to apply some correction factors. So, how are you going to estimate the productivity? Choose the ideal production from the curve. As I told you, if you know the dosing distance, if you know the model number, directly you can choose the ideal production value from the curve. Then, according to your project site conditions, apply the correction factors. Okay, what are all the correction factors we are going to discuss next. Okay, then multiply both, you will get the actual production for your actual site condition. So, we are going to discuss how to estimate that. So, as I told you, these production curves are drawn based upon ideal conditions. What are the ideal conditions? It is drawn assuming 100% job efficiency. That means your machine is going to work for 60 minutes in an hour. Okay, so that is what is the assumption. But in your real project site, your machine may be working just for 30 minutes or 45 minutes or 50 minutes. So, you have to apply the correction factor accordingly. Okay. Then it is based on the assumption that the machines are power shift machines. That means they are based on torque converter, automatic gear change. Okay. So, their maneuver time is only 0.05 minute. But if your machine which you are going to use in your site is based on direct transmission, manual gear change, then accordingly this fixed time will vary. It may be 0.1 minute. So, you have to apply the correction factor accordingly. Okay. And the curve is valid only for the soil density of say 1365 kg per meter cube, loose meter cube. It is given in loosened state, 1365 kg per meter cube. But the soil which you are going to handle in the project site, say if it is denser than this, say if it is 1700 kg per meter cube, okay, obviously your productivity will get reduced. Okay. If it is going to be denser than this, obviously your productivity which you are going to realize will be lesser. Okay. So, in that case you have to apply the correction factor accordingly. Then the coefficient of traction assumed for the track machines is 0.5 or better than that, or wheel machines it is 0.4. So, in your project site, if the coefficient of traction is going to be lesser, so then accordingly you have to adjust the productivity which you have chosen from the curves. Okay, you have to apply the correction factor. If the traction is going to be lesser, your productivity will also be reduced. How much percentage is going to reduce? It depends upon the correction factor that you can refer the literature for the correction factors. Okay, I am just giving you a broad guideline. You have to refer to the either the equipment handbook or the appropriate textbook as I mentioned by Purify et al. So that you can get these values. You can come to know about these values. So, this table shows you what are all the correction factors which are to be applied, okay, for that the particular curve. So, as I told you, you are going to use this curve, you are going to use a value from this curve which are valid for the standard condition. So, according to your project condition, you have to apply the correction factor and adjust this value. That is what we are going to do. So, what are all the correction factors? See, it depends upon the operator skill. Say that curve, the ideal curve was based on the assumption that the operator skill is excellent. But if your operator skill is poor, then accordingly you apply the correction factor. What is the correction factor? You refer the literature and pick up the value. Similarly, the material type, okay, your material, say very tough material, say as I told you, it's very sticky to handle, then in that case the productivity will be less. In the same sense, if the material is going to be totally non-cohesive sand, in that case also it won't easily roll in front of the blade. So that case also productivity is going to be less. If it is going to be rock pieces, short rock, it's going to be difficult for the blade to push. So in all these cases, you have to apply the correction factor according to the type of material. So those factors are available in the literature. Then if you are going to adopt some productive dosing methods like slot dosing, side by side dosing, that's what we discussed earlier. So these productive methods will enhance the productivity by reducing the end spillage. So in this case, it's going to be better than your ideal condition. So whatever you have chosen from this curve, we have chosen values from this curve. So your values should be better than this curve because you have adopted slot dosing method or side by side dosing method. So in this case, your correction factor will be greater than 1. Correction factor will be greater than 1 because your productivity will be increasing. Similarly, visibility. If you are working in a place in a foggy area, dusty area, visibility is very poor. In that case, you have to reduce the productivity taken from the ideal curve. So that means your correction factor will be lesser than 1. Similarly, obviously, in most of the cases, your machine will be working for 45 minutes or 50 minutes an hour. So in that case, we have to apply the job efficiency. So accordingly, the correction factor will be lesser than 1. So the curve is valid for power shift mode, that means torque converter mode or automatic gear change. If you are going for direct drive, the maneuver time will increase. So your productivity will be reducing. So accordingly, you have to apply the correction factor. And depending upon the grade percentage, that means slope. So this curve value is based on the assumption that you are operating the machine on a flat terrain. So but in your real project site, if you are going to move up the slope or down the slope, then accordingly your productivity will vary. If you are moving up the slope, your productivity will decrease. Obviously, your grade resistance will increase, your speed will reduce, your cycle time will increase, your productivity will reduce. If you move down the slope, your productivity will increase. Why the productivity increases? So your machine speed will be more when you move down the slope. As the machine speed is more, the cycle time is reduced, so the productivity will be increased. So according to the percentage of slope in your haul route, you have to calculate the correction factor. Say your ideal curve is based on 0, that means it's for a flat terrain. It is for a flat terrain. The correction factor is 1. So if you are also going to work on a flat terrain, you need not apply any correction factor. Correction factor is just 1. But if your terrain is going to be down the slope, say the slope percentage is 10% or minus 10%, minus 20% or minus 30%. In that case, your productivity will be increasing. So that means your correction factor will be greater than 1. So it may go like this. So this curve you can get it from the equipment handbook or the literature. Okay, I have just drawn it approximately to show you. So if you are working in down the slope, my correction factor is greater than 1. If I am working up the slope, my correction factor is less than 1. It is because down the slope my productivity is going to be high. Okay, up the slope my productivity is going to be lesser. That is why my correction factor is less than 1. Once you take up the correction factors from the literature, okay, or the equipment handbook, and you have chosen the productivity value from the ideal curve, you multiply both, you will get the real production value for the actual project condition. So this is how you have to estimate. So we will work out a problem using this methodology so that you will understand better. So far we have discussed about 3 different approaches to estimate the productivity of the bulldozer. One is using the production curves. Okay, so using production curves which are drawn for the ideal conditions. Okay, so we choose the value from the corresponding production curve which is supplied by the manufacturer and apply the correction factors according to the project conditions and find the actual productivity for the project conditions. That is one way. The other method what we learnt is, so we need to estimate the blade load, okay, we need to know the blade capacity and then we need to determine the cycle time. So like how to determine the cycle time? To determine the cycle time, you need to know the distance. So all the parts of the cycle time, say your fixed cycle time and the variable cycle time. So fixed is nothing but your the man-hour time, okay, like depending upon whether the mode of transmission is direct or manual gear change, or it is power shift mode or torque converter or automatic gear change. Accordingly here the man-hour time will vary. Then the variable time, so if you know the haul distance, if you know the dosing distance and if you know the speed of the machine, you can calculate the variable time. So to know the speed of the machine, you can take the help of the performance chart. So you know already how to use the performance chart. Say for example, if you know the actual project conditions, like what is the rolling resistance, what is the grade resistance, then using the performance chart you can find the corresponding speed, okay, corresponding to the total resistance. So from that you can find the speed, so that will help you to find the cycle time. So this is one approach. The other approach is your thumb rule formula. So your thumb rule formula, say as a function like your productivity as a function of the horsepower of the machine and the dosing distance. So these formula available in the equipment handbook supplied by the manufacturer. So there are different approaches to estimate the productivity of the machine. So let us work out some problems so that we will understand better how to estimate the productivity of the bulldozer. So in this problem we are going to estimate the productivity of this power shift crawler dozer. So power shift, so it is automatic gear change, so you can assume the man-hour time. So the dozer is with a straight blade, it performs a slot dosing operation. The slot dosing operation, you know that we adopt it so that we can reduce the end spillage and you can increase the productivity of the bulldozer. So in this method for this particular project, we have adopted slot dosing operation, and the dozer is excavating and moving material to a distance of 60 meter from the beginning of cut. So the dosing distance is given, okay, your dosing distance is 60 meter, so that is given. The material is found to be dry non-cohesive silty sand. So I hope you remember. So the productivity of the bulldozer depends upon the type of the material. Say if it is going to be cohesive material, it will be easy for the material to roll in front of the blade, okay. So in that case pushing will be easier and the blade will have a higher productivity. But in this case, in your problem, it is given it is dry non-cohesive silty sand. So this kind of material will behave like a dead material. It won't roll properly in front of the blade. So its productivity is likely to be low, okay, that you have to note it. And the unit weight of the material is given 1750 kg per meter cube in bank state. So you have to clearly note that the volumetric measure is clearly specifically expressed in bank state. I hope you remember what is bank state. Bank state is nothing but the natural state. Before you disturb the earth or before you excavate the earth, that natural state is called as a bank state. The material is expected to swell 14% when excavated. From the natural state to the loose state, it swells to 14%. Okay, so this will help you in the conversion. Say for example, from the bank unit weight, I wanted to convert it into loosen the unit weight. I can use this swell percentage to make the estimation. Dosing operation is carried out on a downhill, so with a 15% grade. So your machine is moving down the slope, so this is obviously going to help you in enhancement of the productivity. The operator is assumed to have average skill, okay, not excellent skill, he is just having average skill, and it is a machine is operated in foggy condition, so it means the visibility is going to be poor, and the job efficiency is given as 50 minutes hour. That means the machine is working for 50 minutes in 1 hour. You are going to estimate the unit cost of the earth moving operation. So before moving further, so let us try to recollect what we learnt earlier. So in this we are going to make use of the production curves supplied by the manufacturer for the particular model. I hope you remember the sampler production curves which I have shown you earlier. So if you know the dosing distance, I can find the production curves. So in this case, the dosing distance is given as 60 meter. You can see the dosing distance is given as 60 meter. So corresponding to the dosing distance, if you know the model, you can calculate the productivity. So these curves are just some sample the curves. So the actual curves you are supposed to get it from the equipment handbook. I am just showing some trend of the variation of the productivity with the dosing distance. It just shows some approximate representation. The actual values you can get it from the equipment handbook. Okay. So corresponding to 60 meter dosing distance, what is the productivity for the actual model, you have to take it, and the productivity you will get it in loose meter cube per hour. And hope you remember, these curves are valid only for these ideal conditions. So 60 minute hour, but in your project, in this problem, we found that the machine is working for 50 minutes an hour. So you are supposed to apply the job efficiency. You have to apply the correction factor accordingly. So this curve is applicable for power shift mode, automatic gear change. So in this problem also you have the automatic gear change, so no need to apply the correction factor. But this curve value, okay, so this curve value is applicable for a soil density of 1365 kg per meter cube. So in our case, the soil density is given as 1750 kg per meter cube in bank state, that is to be noted. The soil the bulldozer is going to move is of density 1750 kg per meter cube in bank state. But the curve, the production value, what you have chosen from the curve corresponds to productivity of 1365 kg per loose meter cube. So we need to compare both this material, okay, and apply the correction factor accordingly. Then other things like operator, the curve was drawn for excellent operator skill. So in our problem the operator skill is average. So accordingly you have to choose the correction factor and apply. So your correction factor is going to be less than 1. Because it is average skill, it is going to reduce your productivity. Similarly, the material type is non-cohesive silty sand in the problem we have discussed. Okay, so that will definitely reduce the productivity. So the correction factor is going to be less than 1. Slot dosing, you have adopted slot dosing method in your problem. So that means that will help to increase the productivity. So your correction factor is going to be greater than 1. Visibility is poor in the problem what we have discussed. So that will reduce your correction factor. The productivity will reduce. Obviously, we are working for the 50 minutes an hour. So accordingly, the correction factor should be applied. So in this problem, we are moving down the hill. So the grade percentage is minus 15%. So accordingly, you have to choose the curve supplied by the manufacturer. Okay. So corresponding to what is minus 15%, you have to find the correction factor. Obviously, I told you it may be. So this is 0. The ideal curve is drawn for level terrain. So the grade percentage may go like this. So what is corresponding to minus 15%, you have to choose approximately. So what is the value corresponding to minus 15%? So these are just representative the trends. You have to get the actual value from the equipment handbook. So what is the value corresponding to minus 15%, you can take it approximately. So that will give you the correction factor. Obviously, in this case the correction factor is going to be greater than 1 because it is going to enhance the productivity. So you are going to choose all the correction factors, appropriate correction factors from the equipment handbook for this particular project condition. Okay, and you have to choose the productivity value for the corresponding model and the corresponding dosing distance from the production curve supplied by the manufacturer. So if you know both these values, we can do this the problem. Okay. So after you estimate the productivity, you are asked to estimate the unit cost of proposed earth moving operation per bank meter cube. That means cost per bank meter cube of earth moving operation. You are going to find it. Cost per bank meter cube of earth moving operation. So that is nothing but your hourly cost associated with the machine divided by the hourly productivity. If you know both these values, say this is rupees per hour, this you have to calculate in the bank meter cube per hour. So if you know both these things, I can get what is cost per bank meter cube, unit cost of production. So which is a very important parameter which we use when you plan for a bidding. So when you go for unit rate contracts, you need to know what is the unit cost associated with the every activity. Okay, we need to make the accurate estimation of the unit cost of every activity. Okay. So, for that you need the information on the cost associated with the machine and the productivity associated with the machine. Okay, that also forms a part of the unit cost. Okay. So, the cost data is given to you directly. Already you know, in the previous lectures we have worked out, we have seen how to estimate the cost associated with the various machines, like what are all the ownership cost and the operating cost we have worked out for the equipment. So, using that methodology you can find the owning and the operating cost of the dozer. In this problem it is given to you directly as rupees 1100 per hour, and the operator wage is given as rupees 350 per hour. Let us work out the solution for this problem. As I told you, the first step is we need to find the uncorrected maximum production for the 60 meter push distance for the standard soil density of 1365 kg per meter cube. Okay. So, how will you find the production? So, using the production curves, as I told you, using this production curve for your model and for the dosing distance, what is the value you can take it. This is called as the uncorrected value. Okay. So, this uncorrected value according to your project conditions you need to correct it. Okay. So, first I am going to choose this value from the curve supplied by the manufacturer. Okay. So, that value is found to be 114.68 loose meter cube per hour. This value I am going to adjust according to my project conditions. So, next is, and you should note that this is valid for the soil density of 1365 kg per loose meter cube, but in your project the soil density is different. Okay. So, it is given 1750 kg per meter cube in bank state. So, you have to adjust it accordingly. Okay. Now, the next is visibility correction factor. So, in this problem it is given foggy condition, but the ideal curve is for the excellent visibility. So, you have to apply the correction factor. It is found from the manufacturer as 0.8. So, I have given you the value directly. Operator correction, here the operator skill is average, and for the track mounted machine the correction factor is found to be 0.75. If the operator skill is excellent, you need not apply correction factor. Okay. Then slot dosing, in this problem you have adopted slot dosing. So, from dosing method perspective, this is even better than the ideal curve value. Okay. So, here you can see correction factor is 1.2, because this is going to enhance your productivity. Greater than 1, grade correction, you are moving down the slope. Okay, 15% minus 15%. So, your correction factor increases. It is going to enhance the productivity. Okay. So, from grade perspective it is better than the value taken from the ideal curve. Then material type, here it is non-cohesive silty sand. So, obviously it will affect the productivity, correction factor is less than 1.8. Job efficiency, machine is working for 50 minutes in an hour. So, accordingly 50 by 60, okay, find the correction factor, it is 0.83, but the ideal curve was based on 60 minutes in an hour. So, job efficiency was 1 for the ideal curve. You have to apply according to your project condition, you have to correct it according to your project condition. Then machine transmission factor. So, in this problem also it is automatic gear change, power shift mode. So, you need not apply any correction factor. So, it is just 1. It is same as the ideal condition. In ideal condition also it is power shift mode, here also it is power shift mode. Now, another important correction factor which we are yet to determine is material weight correction factor. As I told you, in this project we are going to deal with non-cohesive silty sand. Okay. Its unit weight is given as 1750 kg per meter cube in bank state. It is 1750 kg per meter cube in bank state. So, this is your project, actual project, but the curve value what we have chosen, productivity value what we have chosen is for the ideal condition where the soil density is 1365 kg per meter cube. So, it is in loosened state, loose meter cube. So, it is in loosened state. So, I need to compare both so that I can apply the correction factor. So, we can compare both only when the volume is in the same type of measure, but one volume is in bank state, other volume is expressed in loosened state. So, let me convert this bank state into loosened state so that I can compare it. Okay. So, how to convert the bank density into the loosened density? I can make use of the swell percentage value given. So it helps you in the conversion. Swell percentage is nothing but bank dry unit weight divided by loose dry unit weight minus 1 into 100. That gives you swell percent. So from the bank state, how much it has expanded to loosened state. That's what is swell percent. Okay. So when you excavate the soil from the natural state, when it gets loosened, okay, how much it swells or expands, that is what is swell percent. Okay. So that's what it's given as 14%. Now let us convert the bank dry unit weight into loose dry unit weight. So you know bank dry unit weight and you know the swell percent. What is unknown is loose dry unit weight. Swell percent is 14 equal to bank dry unit weight is 1750 kg per meter cube divided by loose dry unit weight minus 1 into 100. So you can move this to left hand side. So 14 by 100 plus 1 is nothing but 1.14 equal to 1750 divided by loose unit weight. Now your loose unit weight is nothing but 1750 divided by 1.14, that is nothing but 1535.09 kg per loose meter cube. So this is what is determined here. Loose unit weight is nothing but 1750, that is bank unit weight divided by the 1.14, that gives you 1535.09. So we have converted the bank unit weight into the loose unit weight. So now you can compare both. Okay, your standard condition is 1365 kg per loose meter cube. So now your project condition is 1535.09 per loose meter cube. So obviously your project soil is more denser when compared to the standard condition curve. Okay, so that means this is going to affect the productivity. When the soil is more denser, it is going to be difficult for the bulldozer to push it. So that's definitely going to reduce the productivity. So so you won't be able to realize your productivity as represented by the ideal curve. Okay, so you have to adjust it according to the material weight correction factor. So how to find the material weight correction factor? It is nothing but 1365 divided by 1535.09. Okay, so that gives me the material weight correction factor is 0.8. Obviously, it is also less than 1. It is going to reduce my productivity. So this is your material weight correction factor. Fine. Now let us find the product of all the correction factors. So whatever correction factors we have discussed so far, let me summarize. So one is your visibility correction factor 0.8, operator skill correction factor 0.75, correction factor for slot dosing 1.2, grade 1.3, material type 0.8. Okay, material type correction is different from material weight. Okay, job efficiency 0.83, machine transmission, here we need not, because both the cases it is only power shift tractor, so it is just 1, and material weight correction factor is 0.89. So these are all the correction factors. You find the product of all the correction factors, you will get the answer as 0.553. So this is the value you have taken from the ideal curve. Hope you remember from the ideal curve. Okay, so from the actual ideal curve supplied by the manufacturer, so I have taken the value as 114.68 loose meter cube per hour. So this 114.68 loose meter cube per hour, I am adjusting according to my project conditions by applying these correction factors. That gives the corrected productivity value as 63.42 loose meter cube per hour. So hope you understand. So for the ideal condition, the productivity is very high. But when you adjust it according to your project condition, you can see that the productivity got reduced significantly, 63.42 loose meter cube per hour. Now, the next part, after estimating the productivity, now we are supposed to estimate the unit cost of production, unit cost of earth moving operation. So how to do that? And they have asked you to calculate unit cost per bank meter cube. So that is what is asked in the problem. Okay, cost per bank meter cube. Okay, we need to calculate that. So we need bank meter cube, but what we have calculated so far is here loosened volume. So what you know is the information in the loosened state. So now we have to convert this loosened state value, loosened measure again into the bank measure. So then only we can estimate the cost per bank meter cube. So the same swell percentage formula you can use for the conversion. So your swell percentage is nothing but bank unit weight by loosened unit weight minus 1 into 100. Okay. So the swell percentage is 14 for the soil, and one more thing is, so here it is in volume, loose meter cube, but the formula is in unit weight density. So it is nothing but weight by volume, weight by bank volume. So weight is going to be same for both the cases, only the volumetric measure is different, weight by loosened volume. So weight is going to be same, you can cancel it, minus 1 into 100. So if you move this to the left hand side, 14 plus divided by 100 plus 1, so that is nothing but 1.14 equal to loose volume divided by bank volume. Fine. So now you can calculate. So I need to calculate now bank volume. So bank volume is nothing but production in bank state is nothing but the loosened productivity divided by 1.14. That's it. Okay. So you need to calculate bank state. So it is nothing but bring it this. So it is nothing but bank state productivity is nothing but loosened productivity divided by 1.14. So that gives you 55.63 the bank meter cube per hour. So now you know the hourly productivity in bank state, you have estimated. So you need to know the hourly cost. So how to calculate the hourly cost? Already it is given to you. The ownership and the operating cost is 1100 per hour. Operator cost is given. Okay. So the cost per hour equal to 1100 plus 350 rupees. So that gives you 1450 rupees per hour is the hourly cost. Okay. So now let me calculate the cost per bank meter cube. It is nothing but the hourly cost by hourly productivity. So 1450 divided by hourly productivity is 55.63. Okay. So this gives me the answer as rupees 26.06 per bank meter cube. So this is how you calculate the unit production cost. So this is a very important parameter, as I told you, when you plan for your bidding. So when you plan for your bidding, when you go for unit rate contract, so in the unit rate price what you quote, this part will also form a component of that. So that is why you have to be very careful in the estimation of the unit production cost. For that you need to have a thorough knowledge on how to estimate the cost associated with the machine and the productivity associated with the machine. Then only you can make an accurate estimate of the unit cost of production. Now let us work out another problem, a different approach of the estimation of the productivity. So in this, a crawler type bulldozer is given. It is equipped with power shift mode, so automatic gear change. It pushes a loose soil with blade capacity 6.5 loose cubic meter. So the blade capacity is given to you 6.5 loose cubic meter, and the dozer pushes the loose soil over a distance of 45 meters. So the dosing distance is given as 45 meter and the speed of the machine is given 4 km per hour. Okay. Dosing speed. Okay. Dosing speed is given as 4 km per hour, and maximum reverse speed in the third range is 8 km per hour. Okay. So mostly since the bulldozer is operated for short distances, so the return journey it will be mostly operated in the reverse gear. Okay. So the return speed is given as 8 km per hour. Obviously the return speed will be greater than the dosing speed because the blade is unloaded or empty. So it has to be greater. Now estimate the production of the bulldozer in loose cubic meter if the job efficiency is 50 minutes per hour. So since it is a power shift mode, you can assume the fixed cycle time for the power shift dozer as 0.05 minute. So the maneuver time when you go for automatic gear change machines is 0.05 minute. You can assume that. So that will be your fixed cycle time. This is your fixed cycle time. So now we are going to estimate the productivity of the bulldozer. So with the available input data. So how to estimate it? So you know the blade capacity, you know the blade load, okay, that is known. So you know the haul distance, the dosing distance is known. So it is known. You know the speed of the machine. If the speed is not given, in that case you have to go for the performance chart. With the help of performance chart, you have to find the speed. But in this problem, speed is given to you directly. Okay, so you know the haul distance and speed, so you can calculate the cycle time. So based on using this input parameters, I can estimate the productivity of the bulldozer. So let us see how it is done. So first, the total cycle time is nothing but fixed cycle time plus variable cycle time. So the time needed for cutting and pushing the earth and the returning back. Okay, so the return time plus the maneuver time. Your maneuver time is nothing but fixed cycle time. Maneuver is nothing but time for changing the gears, increasing the speed or decreasing the speed. Okay, so those things comes under the maneuver time. For this power shift mode, it can be taken as 0.05 minute. So now we have to estimate the variable cycle time. So that depends upon your haul distance and the speed. So variable cycle time is nothing but, it is made up of dosing time and the return time, onward journey, return journey. Okay, so dosing time, you know the dosing distance 45 meter and the speed is given 4 km per hour. So let me convert let me find the dosing time. So the distance is given as 45 meter and the speed is given as 4 km per hour. So let me convert this kilometer per hour into meter per minute. Okay, the conversion factor is 16.67. 1 km per hour is 16.67 meter per minute. So multiplied by 16.67. So I will get the answer in minute. So it is nothing but 0.67 minute. Okay, you can simplify and get it. Similarly, the return time. So return time, it's the same distance, 45 meter, but the speed is different. Speed is higher. Here it is 8 km per hour. So convert it into meter per minute, 16.67. So that gives you the answer as 0.34 minute. So your return time is 0.34 minute, dosing time is 0.67 minute. Okay. So now your total cycle time you are supposed to calculate. Total cycle time is nothing but your maneuver time. Maneuver time is your fixed cycle time 0.05 and the dosing time 0.67, return time is 0.34. Add everything, you will get 1.06 minute. That is your cycle time. Now you calculate the productivity. Okay, I need the productivity in loose meter cube per hour. So how to calculate that? I know the blade load. So the blade load was given to you as 6.5 loose cubic meter. Okay, so use this value 6.5 loose cubic meter divided by the total cycle time is 1.06 minute. So I need answer in loose meter cube per hour. So let me convert this minute into hour divided by 60. Okay, 1.06 divided by 60. And one more important thing, you have to multiply it by the job efficiency. So you are going to work for how much time in a hour. Okay, that is job efficiency, working efficiency. 6.5 divided by, okay, let me simplify, 6.5 into 60 divided by 1.06. So what is the job efficiency? It is nothing but it works for 50 minutes in a hour. It is given in the question like the job efficiency is 50 minutes per hour. So it is 50 by 60. So you can get the answer as 306.60 loose meter cube per hour. So this is your final productivity. So this is one way of estimation. So depending upon the input data, accordingly you can choose the approach. So now we have come to the end of the lecture on bulldozer. So let me summarize what we have discussed so far. So as you know that bulldozers are versatile machines. So because it is used for different applications. So not only for the earth moving operations, We can also use it for cutting the trees, ripping the rocks, and for assisting other missions. So, it is used for n number of applications. So, that is why we call it as a versatile machine. So, and we saw that depending upon the type of connection between the blade and the tractor, we can have different types of blade movements, pitching, tilting and angling. So, if you have a C frame, then angling is possible, angling and tilting is possible. So, if you have a tilt cylinder and pusher arm arrangement, in that case only pitching and tilting are possible, angling won't be possible. So, according to the type of connections, the blade movements will vary, and you can assess the performance of the blade using the parameters like cutting ratio and load ratio, and we discussed that if the dimension of the blade is smaller, the cutting ratio and load ratio will be higher. So, for the straight blade, as it is smaller, it is higher, the cutting ratio and load ratio is higher when compared to the U blade. And the other important thing is, we have also seen what are all the different productive dosing methods which are adopted to reduce this spillage, end spillage, slot dosing and blade to blade dosing. Okay, this can help you to increase the productivity of the earth moving operation. And we have discussed about what are all the factors which affects the bulldozer productivity, like the type of the blade, material type and the cycle time. And we have worked out illustrations on how to estimate the productivity of the bulldozer using different approaches based upon the input data available. So, these are the references which I have used for the preparation of this lecture. Okay, you can go through some of these textbooks to get more information related to this topic. In the next lecture, we will be discussing about the scrapers. So, scraper is also another earth moving machine. Okay, so we will be discussing about the different types of scrapers, applications and illustrations on how to estimate the productivity of the scrapers. Thank you.